Hello, welcome to Dalwood Academy. In this video, I'll be going over how to calculate the instantaneous rate of change as a function for any particular given equation or function. Now, the goal here is, if you've been following the series of videos that I've been making regarding the instantaneous rates of change, the previous video we covered how to calculate the instantaneous rate of change at a particular point, which would generate the exact value for the IRC. And that's all great and awesome if we know the particular point where we want to find that instantaneous rate of change. But a lot of times we want to determine the function or something along the lines that we can use for any point along a given graph. So let's say I have this function here. If you look at the whiteboard, we have f of x equals 3x squared minus 2x. Now let's say I wanted to find an equation for the IRC I could just punch in any x value along the function, and I would be able to get the rate of change or the slope of the tangent crossing that function at that particular point on any point I want on the function. So just before I get started, I wanted to ask, if you haven't subscribed, please subscribe to my channel, and that'll be wonderful. We'll be able to grow more and more together. I'll be adding more videos relating to math and sciences. Also, I'll be getting to some biology, biochemistry, physics, and other courses in the near future. And if you like this video, please like and share with your friends. My name is Joe. I'm a professional tutor for about 10 years now, and I've been doing this for a very long time. I've helped over 500 students in person and online. So please, if you want to keep in touch with the channel, and it would be a great resource for your academic achievements and growth at school, high school, college, university, and maybe even in your professional life if you need to touch back onto certain concepts in math and science. So we'll get to it. If you remember the previous video, what we did is we applied the first difference, which is also called the delta process in some books and some universities. We also can call this the first difference method. So really, the idea is that we're going to apply a limit for the function. So the limit as h approaches 0, and we'll state the function. It's f of x, or f of x plus h, minus f of x all over h. And the goal here is that we're trying to get very, very close to the point of interest, where that difference in the terms of the x values is actually going to become 0. So at this point, we can't sub in h equals 0 into the limit, because that would give us an undefined situation. So the goal is, let's put in our function. We're going to use this x plus h representing a second arbitrary point from the point of interest. And eventually, if we can cancel out h from the numerator and denominator, we will then be able to sub in h or apply the limit and get a solution. So moving forward, you can see it's pretty standard. I would suggest that you continue along putting a limit h approaches 0 at every step until you come to the last point of subbing in h equals 0 into the function. So let's apply, 3x plus h squared minus 2 times x plus h minus, and then here what I do is I open a bracket, or you can open parentheses, because that negative is going to distribute when we sub in f of x. So we know f of x is 3x squared minus 2x. And that's all over h. Okay, so we're getting somewhere now. This is a squared. And this is, so I'm just going to have to erase just something very quickly. This is just x plus h, and that's all of that squared. So the next step, limit h approaches 0. I'm going to expand x plus h, so x plus h squared. So we know that is a binomial squared. And binomial squares if you remember like a quick note, I can write that here for you. So note, whenever you have a plus b in parentheses squared, that's basically a squared minus 2a plus 2ab plus b squared. Same thing applies if you have a difference. So if it's a minus b squared, this generates a squared plus, minus 2ab plus b squared. So those, you should memorize those by now. It's always good to remember those as you go, but this is just like a quick refresher on the expanding simplification of binomial squares. So let's expand here further. So I'm going to keep the 3, and then we have x plus h squared. That becomes x squared plus 2xh plus h squared, close parentheses, and now I'm going to distribute the negative 2. So this negative 2 applies to both the x and the plus h. So as you can see, this is all just rudimentary at this point. You're just subbing into the formula. Instead of putting a value in the previous video, we put a value in for x, like 2 or 3, something that was given to us in a problem. Here we're just going to use any arbitrary value x or an unknown x value on the function. So in this case, it's generating an equation in terms of x. So that's the goal here. So that would be negative 2x minus 2h, and then I'm going to distribute this negative here with these two terms, so negative 3x squared, and then plus 2x, and that's all over h. All right, so then we also have limit h approaches 0, and then we're going to expand further. So again, this is just the same concept that you've learned from grade 9 and grade 10. Nothing has changed. It's just that you see some variables. You're involving two variables, in this case, x and h. Eventually, you're going to get rid of the h term. So we'll expand further, 3x squared plus 6xh. Let me just bring that closer. 6xh plus 3h squared. And what we have here is negative 2x, and that should be 2h here. So minus 2x minus 2h minus 3x squared plus 2x. This is all over h. At this point, we can continue to simplify as we go. So instead of, taking up too much time, we start collecting like terms. So if you notice here, we have negative 2x and positive 2x. Those cancel out. We also have 3x squared and negative 3x squared. Those cancel out. And which is great, because now the three terms that are left, they all have h in common. So we can factor out the h from all those three terms and then cancel it out with the denominator, which is our goal for the difference quotient. That's the key challenge, is to cancel out h from the denominator. So limit h approaches 0, and now we're going to factor out an h. What's left is 6x plus 3h minus 2 all over h. I'm going to cancel out h, and then now I'm going to apply the limit. So there's no need for me to write limit h approaches 0 anymore, because now I'm applying the limit. So we sub in h equals 0 into the function. What's left is 6x, 3 times 0 is 0, minus 2. So 3x minus 2 is, 6x minus 2 is our remaining terms. And what this represents is the equation for the instantaneous rate of change. And that's very important. So now I can take any point, any valid point along this function, anywhere, any x value, choose that point and sub it into the instantaneous rate of change equation and actually get the slope of the tangent or the instantaneous rate of change at that x value. So that's a very, very important concept with pre-calc and also into first year calculus. and you'll also see that in some advanced functions courses. But just keep that in mind, that we found the equation for the slope of the tangent or the instantaneous rate of change, and that can be applied to any point that is valid along the original function. Okay, so if you like this video, thanks for watching, and please give it a thumbs up. I'll be interested to hear any comments you have. If you have any questions, you need any clarifications, just comment please in the section below. Subscribe to this channel, trying to grow it and bring more resources available to you and make it more interesting with more different types of projects and whatnot. So thanks a lot, and thanks for coming to Dawit Academy. Take care. Bye-bye.